Hey, and welcome back to another video. And in this video, we're going to take a look at how we can write some UI tests for our SwiftUI application. So when you're actually writing UI tests, similar to when we're writing unit tests, you actually need to create a UI testing target. So that's the first thing we need to do. So you're actually able to do this two ways. So the first way is by clicking on your Xcode project here, and then clicking the plus button at the bottom here where your targets are. Or alternatively, you can go to File, New, and then Target, and then select it from there. So when you create a new target, you want to go down and you should see that you actually have something called a UI testing bundle. So you don't want a unit testing bundle because we already have one of those. You want a UI testing bundle. So hit next. Cool. And then you just want to hit next on this. So hit finish. And then now you should see that you have a new target here for your UI test and a new folder specifically for your UI test as well, which is great. Cool. So before we actually just dive a bit deeper into writing some UI tests for our people screen, I just want to look at what gets automatically generated for us. So the first thing you'll see is you get two files generated for you. And the first file here is this one, where it's just literally a template for your UI test. Now the second file you'll get is a launch test files, and this is actually where if you want to write a snapshot test. And what a snapshot test is basically if you want to verify that your screen looks the same at a certain point against some kind of image and whatnot. So I briefly just want to look at the code here. If we just go into our UI test file, because we're not actually going to be writing snapshot tests, and you'll see that you actually have this code here called app and XCUI application and app.launch. So what is this? Well, when you're writing UI tests, essentially what you're doing is just giving your app instructions on what it is you want it to do, and then you assert and validate that what you see on the screen is correct. So what we're essentially saying here is we're getting that application, and this is why when you're writing your UI test, you want to make sure that because you're using your real application, you're not testing against a real service, because if your service goes down, such as the API that we're working with, so do your entire test. Instead, what you want to do is actually use something which we'll use later called launch arguments that allow you to pass data through and mock data via dependency injection. And if you want to learn more about mocking and dependency injection, then check out my previous videos within this course. So because we're doing this now, where we're going to write our people test, I actually want to create a new files. So what I'm just going to do is just delete these two files here, and then we're going to create a new folder here called people. And then within this folder, we're going to create a new UI test case class called people screen UI test. Cool. So like I said before, you don't want to create a bridging header because we don't need that. Cool. Sweet. Okay. So before we actually set up our test like so, let's actually just go into our people view. And then let's just launch this on, well, not launch, but let's just run this on our SwiftUI preview. And let's just discuss what are the test cases that we actually want to write. Cool. So if we just run this, so there's actually two test cases that we want to write in our UI test. And the first one is that we want to validate that when you run this, we actually get the right amount of people on the screen with the mock data that we're going to pass through. And if we throw an error, we want to make sure that we see an error on the screen as well. So that's the two requirements that we're going to write test for within our UI testing file. Just go back to our file, and I'm just going to remove this because we don't need it pinned. Let's get rid of the canvas for now. Cool. So the first thing we want to do is in our UI test file, we actually want to set up our, use our setup and use our teardown. So let's actually create our setup and our teardown within this file. So we'll type this one out together. So I'm just going to delete everything here and we'll just start fresh. So the first thing you want to do at the top here is you want to create a variable for your app that you're going to basically launch within your UI test. Cool. And then we're going to create a setup function. Well, we're not going to create, but we're going to use the setup function and override it. And we want to use the one where it's not got the class. Cool. And then within our setup, what we want to do is call a property called continue after failure and set this to false. Now the reason why you want to call this is because if your test fails, you don't want the UI test to carry on, you want it to basically stop, which is why we set this to false. Then we want to set our app like so, and then we want to call launch. Cool. So what we're saying here is that if it fails, we want you to basically stop. We're going to create our app, a fresh app every time, and then we're going to launch our application as well. So in our teardown, we're going to set our app to nil, like so. Cool. Sweet. So like I mentioned before, we're not actually able to actually mock our view model since we have to give our app instructions on what it is we want it to do. When you write your UI test, you don't actually want to be connecting to a real service, since like what I said before, if your service goes down, then so do your tests. So how can we actually get around mocking if we can't actually pass in mocks within these tests? Well, what you can do with your test is actually pass through flags in between each launch, and we can do this by using launch arguments and launch environments. So what this will do is it will allow us to actually pass data into our main app. So when our UI tests are running, we're able to actually change what is used between each run. So in our application, so in our test, what we're going to do is set a launch argument for checking to see if this is a UI test. So we'll say app.launch argument. And if you actually look at the launch argument, it's actually an array of strings. So you can actually pass in multiple launch arguments that you want. So you can have a whole different amount of like parameters that you want to check against. And we're just going to call this argument dash UI dash testing. So if we see this argument in our main application, we will know that this is a UI test that we're currently running. It's not the main application. Cool. And then what we're going to do is set a launch environment. And the launch environment is actually a dictionary of a string. So if I just click on the option key command here, you'll see here it's a string. So with our launch argument, we can actually specify a key value pair that we want to use within our application. So what we're going to say here is networking success, and then we're going to set that to a value of 1. So what this will allow us to do is we can actually grab this key and then access the value that we want. So you might be wondering, when would you want to use a launch argument and when would you want to use a launch environment? Well, the way I look at it is, let's say you want to have a launch argument here to basically check to see if it is a certain type of test, like a flag, then that's when you want to use an argument. But let's say if you have a value that could actually change and dictates the way that your code runs, I would probably stick to using a launch environment, because what we're actually able to do here is basically to change whether the networking request we're going to make is successful or not, which is why you have a launch environment. Cool. So now we actually have these set up, we need to write code in our main app to actually check these flags and then React and configure itself based on these arguments and environments. So we're going to build a helper within our main application. So within our project folder here, let's create a new group, and then we're going to call this group UI testing. And then within this, we're going to create a new file, a new Swift file called UI testing helper. Cool. So the whole purpose of this file that we're going to create is so we can actually access those launch environments and arguments within our main application, and then we can actually change the way our code is, configured depending on what has been set. Cool. So in here, let's just create the skeleton for our UI testing helper, like so. And the reason why I'm marking this as a struct and not a class is because we don't really need to observe this value. This is just going to just give us, what it is that we need. So we don't need to create an instance of it and, share it across, different objects. We just want to get a value from our launch arguments. Now, the main thing to keep in mind here as well is that this code that I've wrote here now, if I was to just keep on typing code, this would actually be bundled within our final application that you upload to the App Store. I actually want this to be available when we're actually, performing, tests and UI tests. And when we ship our app, we actually don't want this code to actually be in the final bundle that goes onto the App Store. So how can we actually exclude this code I'm about to write from our app build and make it only available when we're running our tests within our app? Well, we can actually use something called macro preprocessors that allow us to basically exclude code out if it is being run in a in a non-debug environment. So in order to do that, what we want to do is that this whole file, we essentially just want to wrap this in an if debug. So what we're going to say is pound and then if debug, and then after this we're going to say end if. So this will ensure that when you run your app on your simulator on your device, this will be available. But if you was to like publish and put this app onto the App Store, this code will actually not be within the final app bundle. So it will actually help reduce the size of your application. So now in our helper, we actually need to create a property to tell us that we're actually running a UI test. So in order to do that, I'm just going to create a static computer property that tells us that it is a UI test. Cool. So this is just a bool. So you might be wondering, okay, so we've got this is UI testing, but how can I grab the value from this launch argument to tell me that this is a UI test? Well, in order to actually grab a launch environment and a launch argument, you actually need to get it from the process information whilst your application is running. So we can do that by using the process info API. So let's do that now. So we're just going to say process info dot arguments, and now within our arguments we can now check to see if this argument here, UI testing, exists within that array. So we can just say contains the flag UI testing, like so. Cool. So now that we've done that, we're actually able now to basically check to see if the current mode that our app is running in is either a UI test or if it's just like a standard app run when we're running it on the simulator or on our device. Now, me personally, when I'm actually, testing things out and working with like UI testing helpers, I prefer to basically do all of this stuff within an app delegate. Now, when you're working with SwiftUI, you actually don't get an app delegate at all, so you need to actually create one. So let's actually just create one now. So let's go into our main app entry point. And within here, you'll see that we actually don't have an app delegate, so we need to essentially create one. So let's just create one underneath here. So let's just type this one out together. So we're going to say class and then app delegate. And then it's going to subclass UI responder and then UI application delegate, like so. Cool. And then within here, we've got to have the did finish launching with options, like so. Cool. So if you never saw what this is, essentially what the app delegate is it's literally just like the entry point for when your app is basically like set up. So you can literally like configure stuff before your app launches. That's what this is. Hence why this function is called, did finish launching with options. We can configure stuff, before our app has finished launching. So within this function, we want to return true as well. Cool. Sweet. So now within our app delegate, what we essentially want to do, we want to write some code that essentially allows us to print out if we're running a unit test, if we're running a UI test or not. So within here, what we're just going to say here is if debug and then end debug, end if, and I'll say print, and then we're going to say just a message here and with an emoji to say, with this little dude, I'm just going to say is UI test running, and then within here we're just going to do that string interpolation and just say. So what we're doing here is we just go to essentially say is that when our app launches, if depending on how it's been launched, we're going to essentially just print out if it is a UI test that's running or not. Now we set up our app delegate, but right now this app delegate is not actually hooked up to our SwiftUI app. So what we need to do is actually hook this up to here. So let's go in here. I'm just going to say app UI application delegate adapter like so. And then we just need to say here app delegate dot self and then var app delegate like so. Cool. So now this links our app delegate to our main app entry point like so, which is what we want. Cool. So if we want to actually test this out, what we could do is actually just run this on the simulator. If we just go into our logs here, you'll see here that when we run this on the simulator, it actually says that is UI test running is false, which is correct because we're not running a UI test, we're just running our application. But if I also go into our people screens test, and let's say if I just to create like a dummy, function, or test function, I'm just going to say test dummy, and we'll just make this fail. If I was to just like build this and just run this UI test, you should see that it stops on this line here. And if I just carry this on, you'll see that it actually says the is UI test is running is actually true. So it's actually picking up now that whether we're running a UI test or if we're not running a UI test. So now we're actually able to run our app normally, and then we're able to actually also run our app and distinguish whether we're running it normally or a UI test. So because of this, we actually need to create mocks for our actual view models. So depending on whether it's running as a UI test or not, we can actually change what is actually injected within our, PeopleView model. So we actually have quite a few mocks already within our unit tests. So what we want to do is go into our unit tests, and all the mocks that we currently have within our unit test, we essentially want to move these out now into our main app target, because we want to literally give our unit test and our main app for our UI test access to use these mocks rather than repeating these files again. So let's create a new folder here called mocks, and then we're just going to move each one of them within this folder. So I'm going to call this create, and this is going to hold these create mocks that we created in here. Let's go inside of here, move that there, just remove this folder, and we're just going to repeat this for each one. Cool. And then we'll just check our form, and that looks like the last of them. Cool, sweet. So similar to our UI testing file, we actually don't want our mocks to be within the final build that we actually distribute onto like the App Store. There's no point of that being there because we don't want it to be there. So what we're going to do now is actually wrap all our mocks within the if debug, so it's only available when you actually run the application, in the simulator or within some kind of test. So we'll just go to say pound if debug. Cool. So now all of these files won't be included in our final build. So all of these files as well, currently right now, if you click on them, the target is actually still our unit testing target. So right now, our main app can't actually access and use these files if you want to use it. So what we want to do is actually change the target membership to only be our main application, so our unit tests can access them by the app testable import, and also as well our UI testing files will be able to use it within our main application. So you should get an error saying that you can't do this, which is correct because we're within the actual main app target. So we need to remove these at testable imports as well. So let's just do that for each one of these files. So we'll remove that and then just change the target membership like so. Okay, cool, sweet. So now we've got all that set up. So just to make sure that none of our tests are actually, broken and everything's working fine, I'm just going to run all the tests within the project. Now you can do this on your keyboard by using Command U, or alternatively, you can actually go to Product and then test as well, which also has the same command there. So let's just run all our tests and see what happens. And you'll see here that we actually have a build failure. Now the reason why we have a build failure is because we go into our URL session mock protocol, we're actually importing XCT test, which we can't actually do within this target because it's not a unit testing target. So let's actually just take this out. Cool. And you should see that we should get an error here to say that we've got a failure because we can't use XCT fail as well. So instead of using XCT fail, we're just going to use here a fatal error instead, where we just crash it out. Cool. Sweet. So let's try that again. Let's remove our return because we don't need that no more. So now let's try this again, where we try to run our tests and see what happens. And you'll see that our build succeeds. I'll just take out these breakpoints because we don't want all the breakpoints running. Cool. And if you look at our summary for our test, all of our unit tests pass and our unit UI test fails, which is what we expect because we explicitly said XCT fail. Cool. So we're almost ready to write our, UI test for our PeopleView, but we still have a bit more setup that we need to do within our main application. Now the next thing we need to do is we actually need to change the way that we initialize our PeopleView model within our PeopleView based on whether it's a UI test and whether we want our networking to be successful or not. So let's go into our PeopleView, and I'm just going to close this to make a bit more space. And right now we actually have an initializer. Right now we actually initialize our PeopleView model within the PeopleView on one line. But what we want to do now is we actually want to initialize and configure our PeopleView model based on whether it's a UI test or not. So we want to change this and actually write our own custom initializer, and we need to use dependency injection as well. So let's first of all just create our custom initializer like so. And then, like I said before, we want to change what gets in, what view model and its dependencies get injected. We want to change what view model and dependencies are injected within it. So instead of doing this, we want to specify the type like so. Cool. And then the first thing we want to do is we want to check to see if we're running in a debug mode or not. So if it is debug, then we're going to do our UI testing logic within here, or else just default to the standard, view model, PeopleView model with its default dependencies. So we're just going to say here, and then within here, this is if we're not running within a debug context. So this is if you're actually just running a device on like the App Store or Test Flight or whatever. So within here, we just want to use our default view model with its standard dependencies. So in order to access your view model in an initializer, you actually don't do VM like so. You actually have to access it by using underscore VM like so. In here, we need to create an instance of it within a state object. So we're going to say state object, and then create an instance of it like so, and then say people view model like so. Cool. So this will actually create a state object with the wrap value of a PeopleView model. Now we're still going to get some more errors because we've not set it with all the case paths. So we still need to handle our if debug case path here. And what we're going to say in here is that if we are doing a UI test, so if the UI testing is a UI test, then within here we're going to do some dependency injection. But if not, then what we're going to say in here instead is we're just going to copy what we've done here. So we're just going to create a view model with the defaults like so. Cool. So within our UI testing within here, what we essentially want to do is, depending on whether our environment is a success or failure, we want to change what mock gets injected within our view model. So if you go back into your screen test file, you'll see here that we have this flag here, well, not a flag, but this key called networking success. So what this key is going to do is it's going to control whether we actually have a successful response within our view model or a failure using mocks. So we need to actually create a property to actually access this within our UI testing helper. So let's do that now. So let's go into our unit testing helper file, and within here, we're now going to create a new property called networking successful. So let's do that. We're actually able to access those environments again within our UI test by accessing and using the process info API. And then within here, all we simply need to do is just access the key, like so. And then we just want to see if this key is equal to 1. So essentially, we're treating 1 here as true because we can't pass in booleans, we can only pass in strings. So if it's 1, we're just going to say that, hey, this was successful, so we want to have a successful mock. And if it's 0, then we're going to pass in our unsuccessful mock. So let's go back into our initializer here. And within here, we're going to now create our networking mock. So I'm just going to say let mock. And then this mock is going to depend on, we're going to say UI testing helper dot networking successful. And we're just going to use a ternary operator here. So if it is successful, then we're going to use our networking user response success mock like so. And if it isn't, then we're going to use our failure one. Cool. So now what we want to do is actually pass through our mock into our view model. So we should get an error here saying that we've actually got a mismatch because these two are actually not the same type. So to help us get around that, we need to specify the actual protocol that we used for both of these mock, which is networking manager impl, which stands for implementation. So on our mock, we're just going to say networking manager impl like so. Cool, sweet. So now we have that set up. So now you can see the power of using protocols and dependency injection, where it allows us to make our code a lot more flexible and we can pass in different values via dependency injection. So we've actually got that set up now where if we're running a UI test, depending on our environment and our argument, we're going to configure what actually gets returned to us back onto the screen. So now we're ready to actually write our first UI test. So let's go into our people UI test. And the first test that we want to write is just to validate that there's actually 6 items on the screen. So I'm just going to type out the name of this test and then we'll break it down. So now you can see here we have our test that the grid has the correct number of items when the screen loads. So we're just validating that it has the correct number of items. So now that we have our test, we actually need to get our grid within our test, because remember what I said before, when you actually run UI tests, you're essentially telling the UI a set of instructions that you want it to run, which in our case is we want it to basically launch the app and then we want to validate that there's enough items in the screen that we expect. So in order to actually do that, on our people view, we need to actually find a way to basically grab our lazy vgrid, because right now there's no way for us to actually grab it. Now, if you want to do that, you can actually use something called an accessibility identifier. And what that allows you to do is it allows you to give a view and identifier that allows you to basically grab it within your UI test. So on your lazy vgrid, what you want to do after your padding is you want to specify an accessibility identifier. And this is going to be people grid like so. Cool. So now we can grab this view within our UI test quite easily. So let's go back into our UI test and see how we can grab this view. So when you're working with UI tests as well, there's actually a way for you to easily grab UI tests. There's actually a way for you to easily grab UI on the screen. Now, this is provided to you via the XCUI element type query provider. And if we just quickly look at this API, XCUI element type query provider, You'll see here when you look at this API, there's actually a whole bunch of UI controls that you're able to easily access. But it's worth noting that a lot of these, UI elements are actually built from, the UI kit days. So it's not easy for you to just basically get some new, custom SwiftUI views. So if we want to actually grab a lazy V grid, we actually don't have any query items for a lazy V grid here. So we need to find a way to get it. But if we were to use something like a list, we could just simply use something like a tables and we'd be able to access our list like that. But when you're working with lazy V grids and other custom UIs, you may need to use the actual query item of other to actually access other types of elements. So let's do that now. So the first thing we're going to do is we're going to say let grid, and then within here we're going to say app. Now in order to actually access that element with its ID that we specified before, we're going to say app dot other elements, and then now we can put in here the ID that we specified in our accessibility identifier. So we go to PeopleView, we want to get people grid, and then put that within the grid like so. Cool. So now what this will do is it'll actually give us access to the actual grid that we have on the screen. Now one thing I want to do is I want to make sure that the grid is actually on the screen and visible for a user. So we can actually check and validate that our grid is on the screen using a function called wait for existence. So I'm going to write here xct assert true, and within this assert I'm simply just going to say grid dot wait for existence, and then we're going to set a timeout on this of 5. So what this is going to do is it's actually going to wait 5 seconds to see if the grid is on the screen. And I'm actually going to put another message in here that just says the people lazy grid should be visible. Cool, like so. Sweet. So just to see how this works, let's actually just run our UI test. And when you're running your UI test, you actually want to keep mind of the simulator because you'll see what's going on. So let's run our UI test now. So I'm just going to click run. And as you can see, our test passed because it was able to find our people grid on the screen. So just to show you that this definitely works, if I was to change the name of this to like people grids and then run this test again, you'll now see when you look in the logs, it's actually searching for people grids on the screen, and you'll see after 5 seconds, it will say that, hey, I can't find it. And the test fails. So let's just change this back to people grids and then run it. Cool. So our test passes, and now the next thing we want to do is we want to test to see if there are 6 items on the screen when it loads for the first time. So what we need to do is actually give each cell on the screen an ID and essentially validate that the count is correct and their contents. So what we can do is actually use an NS predicate, and this essentially is a query to help you find elements on the screen. And if you have experience with SQL, this type of logic is very similar to what you already know. So what we want to do is we want to query that we will find all the items on our screen with a specific type of identifier. So first of all, let's go back into our people view. And then on our person item view, what we want to do is we want to add in an accessibility identifier. And then that identifier is going to be item underscore. And then here, we're just going to use the user.id like so. So within our test, what we essentially want to do after this line is we want to basically grab any items on the screen that contain item underscore. So let's just first of all type out the predicate. So we're going to say let predicate and NS predicate like so. And then we're going to choose the option where it says format. You can actually pass in arguments, but for this I'm not going to use arguments. I'm just going to put it within the string. So within this bit here, what we're going to say here is I want you to find any identifier, so identifier that contains item underscore like so. Cool. So this isn't too different from what you would, typically write with SQL. And you can see that we're just almost like writing like a like query here. So on our grid, we want to execute a query that searches for any items within it that have an identifier that contains item underscore. So let's do that now. So we're going to say let grid items, and then we're going to say grid dot over elements contains, and then we can say this containing, and then pass in containing, and then we can pass in here predicate like so. Cool. So now if this is successful, we should actually have 6 items within this object here. So we want to do an XCT assert equal, and we want to check to see that our grid items dot count matches 6, and then we're just going to say here there should be 6 items. Cool. So now let's actually just run this and see what happens. So let's just run this. And you'll see that our test actually fails. But you might be wondering, like, why did it fail? Because you would think that you can access it from other elements. Well, let's actually just debug this. So we'll put a breakpoint in here. And we'll actually see that our grid items obviously is 0, which is why it doesn't, match 6. So there's actually nothing within grid items. But how do we know what type of view this is? Because you would think that this is a view and is classed as any other elements. Well, when you're writing UI tests, if you want to actually debug and see what type of view this is, what you can do is you can actually print out all of the children within a view and see its contents. So once to do that, we can just simply do in here PO, and then we can say grid, and then we can say children matching any. So what this will do is this will actually print out all the children within the grid. So let's just print this out and see what happens. And you can see that you actually get like a layout here that shows you everything that's within the actual grid. So if you scroll down, you should notice that you see here that there's a child type any within the grid, and there actually are 6 buttons within here, and you can see the identifiers and their labels like so. So what we actually want to do is we actually want to check for not other elements, because they're not other, instead they're buttons. So let's just change this to buttons like so. Now you may be wondering, why is this like duplicate this identifier? And the reason why this is duplicated is because in our mock we actually don't take into account any kind of pagination. We just return the same data more than once. So that's why this is the same here. So for our UI test, this is fine because we just want to make sure that it's the right number of elements on the screen. So this is actually okay. So let's just stop this from running, and then this time we'll run this again and see what happens. And cool, you'll now see that our test now passes. So if you ever get into a situation where you can't seem to find an element on the screen, the best bit of advice I would give you is to run the command that I mentioned before. So I'll just do that again. So we'll just put a breakpoint in and we'll just run this again. So on the element that you'll want to find the children within it, if you just type out again PO and then the element, which in our case is grid, and if you want to find out what the children are within that element, you can just say children matching and then just say any, and this will print out all of the children within that people grid you can see here. So people grid, and then within the people grid it finds these children matching any. So it's a useful tip for helping you debug your UI tests. Cool. Sweet. Awesome. So now that we've got that in place and we've got our test to actually, make sure that this all, passes and there's actually 6 items on the screen, the next thing we want to do is we want to actually validate that there's actually the right text on the screen as well. So we want to make sure that when we run our test, if I just put a breakpoint on here and just run this again, we want to make sure that we see this information, such as George Bluth, Janet Weaver, and all that, correctly on the screen. So what we're going to do now is actually access our app's static text. So we're just going to check to see if our grid items contains the static text that we see on the screen. So within here, we're just going to say XCT assert true, and then we're going to say grid items. And then within our grid items, we're going to say static text. And then we're going to now check to see if the pound sign, so the ID 1, exists like so. Cool. And then in our next one, we're going to see if the name George Bluth exists. Cool, sweet. So I'm hoping you're seeing where I'm going with this in terms of what I'm checking is on the screen. So I'm just going to literally just type this rest of this out pretty quickly, and then we'll run our test again. So now we've got all of our XCT assert trues to basically make sure that all our text is on the screen. So let's just take this out. And then this time what we're going to do is actually just run our test now like so. And you'll now see that our last test actually fails. And the reason why it fails is because it's not Tracy Morris, it's Tracy Ramos. So let's change this to Tracy Ramos. But you can see here that this helps us validate that we have the right text on the screen. So let's just run this again and see what happens. Cool. And now you'll see that our UI test passes for our screen in terms of loading the correct number of items, which is exactly what we want. So now we've actually done all of our tests in terms of our success and it load on the screen. The next thing we need to do is actually write our UI test for when something basically messes up. So if our API request fails, we want to show an alert on the screen. So let's go back into our people folder within our UI test here, and then within here we're going to create a new UI test case class, and then we're going to call it people failure UI test like so. Cool. And we'll just create that like so. Sweet. So as usual, let's just delete this, and then we're just going to type this out from scratch again, and then I'm just going to copy this and then paste it. Cool. So just to let you know, I know there is a better way of doing this in terms of us repeating it, but the reason why I'm getting you to do this is because repetition actually helps you form a habit of understanding what's going on, which is why I'm not like doing this in a crazy reusable way. It's just more so you can see that the way you're doing it and enforce that learning. So in our people failure test, we just copied over this from our people, screen test. But there is one thing that we want to change here. So previously before we had it where the networking success was 1. This time we actually don't want this to be 1. We actually want this to be 0 because we want to simulate something going wrong. So let's change this to 0, like so. And then now in our people view, because this is 0, this is actually going to use our networking user response failure mock here instead. So within this test, we want to validate that an alert is shown when the screen fails to load. So let's actually just write this out now. Cool. So now we have our test here that basically is going to validate that an alert is shown when the screen fails to load. So when you're actually writing UI tests as well, if you want to access an alert on the screen, it's actually quite easy to do. All you need to do is actually use the alerts query from that UI that I showed you, from that UI query API that I showed you before. So we can just say let alert, and then we can just say app.alerts. And you can see here that as part of the XC UI element query, you're able to access alerts on the screen as well. And then we just want to get the first match because you can only ever have one alert on the screen. So we just care about the first one. And then after this, we want to assert true that you can actually see this alert on the screen. Cool. Cool. So now let's actually just build our project, and then we should see that we can actually run this. So let's actually just run this test and see if it works. And you should see that our test passes, and you can see our alert on the screen there as well. So now the next thing we want to do is we want to actually write a test to see if the text within the alert and the button is actually what we expect. So now we can actually check the static text within that alert. So let's do that now. So we can just say alert.static text, and then we can say URL isn't valid, and then we can just say exists. So we just don't really want to wait for this like we do for the alert, because there's not really any presentation with the alert, which is why we had the timeout in, because it might take a while for it to animate onto the screen. But because the text is already on the screen, we don't need to wait for its existence. So I'm just saying if it exists, and then after this we're just going to say xct assert true, and we're just going to validate that the button within the alert also exists, like so. Cool. So now let's actually just test this out and see if it works. And you'll see that our text, but you'll now see that our UI tests pass. Sweet. So now we've actually done everything with our people screen, and we've saw how to actually give views identifiers. We've saw how to use launch environments and arguments within our main application. We saw how we can actually hook that up with dependency injection as well, to make sure that we can configure our UI test depending on these arguments and environments. And we've also wrote test cases for our success and our failure. So we've actually covered a lot within this UI testing video, and I hope you've learned a lot in terms of how you can actually write better and structured UI tests as well. So if you enjoyed this video, I'd love to hear your feedback in the comment section below. Also as well, if you haven't already, I really appreciate it if you gave this video a thumbs up, as well as subscribe to the channel and hit notification bells to get updates for whenever I release a new video. That's everything from me. I'll catch you on a bit. Deuces.